Hello, my name is Jaeden Monsada, and in this presentation, I will be discussing the physical concepts behind the internet phenomena known as trickshotting, which can be described as the act of launching a projectile in order to hit a target that is considered highly unlikely to hit. Here's a quick video to demonstrate the specific type of trick shot that I will focus on. As you can see in the video, the point is to land ping pong balls into a cup or a pot using a combination of inclines and flat surfaces at varying heights. Now you might be asking, why did I choose this topic in the first place? Not only is it entertaining to watch, but it also provides a simple and clear demonstration of how common forces we experience in everyday life affect an object in motion. So what forces am I talking about here? The purpose of this assignment was to pick a phenomena that involves concepts studied in chapters 1 through 8 in the textbook. As some of you might have guessed, the chapter of the textbook that I will be focusing on in this presentation will be chapter 5, the chapter about Newton's laws and the common forces found in life. First on my list is gravity. From my understanding, anything with mass exerts some pull on the objects around it. The magnitude of this force is directly related to this mass, and since Earth is so massive, we are constantly feeling the effects of its pull, which we call gravity. This can be described as a constant downward acceleration of 9.8 meters per second squared. And now you might be asking yourself, if we're constantly accelerating downwards, then why aren't we falling? This brings me to the second term on my list, which is called normal force. Newton's third law, simply put, says that every action is met with an equal and opposite reaction. In response to gravity, a force that typically opposes this, is the force that the ground or any other surface exerts on any object in contact. The direction of this force is always perpendicular to the surface of the contact. The last force that I want to mention is applied force. Just as the name suggests, it is a force being applied to an object. This type of force is significant because according to Newton's first law, an object will remain at a constant velocity unless acted upon by an outside force, meaning a force is necessary in order to initiate the motion. Now this brings us to the actual phenomena. In this example, I will describe the phenomena in two-dimensional motion rather than three-dimensional motion like it was shown in the video for simplicity, because I'm choosing to focus more on the forces of the ball rather than the direction the ball travels in, which relates more to chapter 4. Anyways, as you saw in the video, it starts with the person tossing the ping pong ball in the air, which is the applied force in this situation. This applied force has both an x and a y component, which represents the horizontal and vertical vectors respectively of the overall force. Since gravity is actively affecting the ball, it descends at an increasing velocity. Since the ball travels in an arc, that means that at some point, the magnitude of the applied force's y component will be equal to the ball's weight. At this point, which can be considered at the top of the arc, the ball's total vertical acceleration is 0. However, its horizontal acceleration remains the same. When the ball impacts the surface of an incline, a normal force will cause the ball to be propelled in the direction that is perpendicular to the surface of the incline. To determine the magnitude of this force, we will use the magnitude of gravity times the cosine of the angle of the surface in respect to the ground. Since the ball hits the surface on an incline, the resulting magnitude will be less than the gravitational force it was met with. This means that on the next surface that the ball lands on, will in turn repel the ball with a smaller magnitude due to it having less time to descend once more and pick up speed on the way down, which can be seen as the progressively smaller arcs in the diagram to the right. To compensate for the steadily decreasing velocity of the ball, the people from the video either throw the ball from farther distances or decrease the distance between each surface. Finally, this process continues until the ball finally lands in the cup. As you can see, although the topic seems simple and mundane, the laws of physics can be applied to anything. That's all for my presentation, and thank you for watching.